Hello. Now we are going to discuss about outline of data structures. So data structure is differ. Data structure is not a programming language. It's different from programming language. So data structure means how I'm going to store the data in memory. How I'm going to organize the data in memory. That is called the data structures. So under the introduction, memory allocation, recursion. So these all are we are going to discuss about the introduction part. So what are the different types of data structures? Data structure generally classified into primitive and non-primitive. So primitive data structures already we are used in C language, that is int A, int B, like that. So integer is a data type, A is the variable. So integer, float, character, pointer. So these are the primitive data structures. Non-primitive data structures means it's A of 10. So this is the array variable. So int A of 10, that is the array variable. So array, list, files. So these are the non-primitive data structures. The list can be classified into two. One is linear, another one is non-linear. So linear means stack and queue. Non-linear means graphs and tree. So stack means I'm going to store the data one by one. So which item I'm inserted last, that item I'm going to remove first. That is called stack. Queue means same, I'm going to insert the data one by one. Which item I'm inserted first, that item removed first. In stack, insertion and deletion happen in one end. But in queue, insertion and deletion happen in different end. So insertion in this end, rear end, deletion in front end. Non-linear list. So trees and graphs. So trees already we know here node, the data can be arranged in tree structure format. So the one node can have more than two childs, that is called a tree. So graph means so this node, one node, more than one edges, that is called a graphs. So graph is different from tree. So tree is always called graph. Graph is all, it's not always called tree. So these are the classic, these are the different types of data structures. So what are the operations of data structures in traversal? Insertion, deletion, sorting, searching. So traversal means I'm going to visit all the node in the tree, whether it is in, sorry, all the node in the memory, whether it's arranged in the sequence order, whether it's arranged in the tree structure format. So I'm going to visit each and every element in the memory, that is called traversing. Insertion, I'm going to insert an element in the array, or I'm going to insert the element in tree. Deletion means I'm going to remove the element from existing array or from existing tree structures. Sorting, the data can be arranged in some specific order. Maybe it is in arranged in ascending order or it's arranged in descending order. Searching, so I'm going to search the particular data in array, that is called searching. For example, this is my array list. So I'm going to search the element. My searching element is 5. The 5 is available in my existing array or not? No, 5 is not available. The searching element is not available in the array. If suppose I'm going to search 2, so 2 is available here. The searching element is available in the array, that is called searching. So these are the different types of operation we are going to discuss in data structures. Then memory allocation. The memory allocation means if I'm initializing any data or declaring any variable, so the memory will be allocated for the particular variable, whether it is the normal variable or array variable. The memory will be allocated according to the type of the variable. The memory allocation can be classified into two types. One is the static memory allocation, another one is the dynamic memory allocation. So static memory allocation means it's fixed. We can't able to change the memory. Static dynamic memory allocation means it's a changeable. We can able to change the size of the memory during runtime. That is called the different types of memory allocation. Then recursion, a function can call within a function. The function call will call the same function, that is called a recursion. A function call function itself. In unit 2, we are going to discuss about searching and sorting. Searching means already we have discussed two different types, linear search, binary search. So linear search means the data arranged in linear format. Binary search means the data arranged in tree structure format. The next one, sorting. So we can arrange the data in some specific order, whether it is ascending or whether it is descending. So two different types of Sorting is a comparison based and non-comparison based. So here we are going to discuss about comparison based in your syllabus. Then stack and queue. Stack means last in, first out. Then queue means first in, first out. So for example, I'm submitting the record. Which record submitted last? That record popped out first. It is that record removed first. So push operation, it's mainly for the two different types of operation. One is push and pop. Push means insertion, pop means deletion. Queue, just I'm standing in a queue to get a ticket. So which person is standing first, that person will receive the ticket first. That is a queue. And in fourth unit, we are going to discuss about linked list. So linked list generally, this is the normal tree format. So linked list, how I am going to represent. So linked list have two different components. So one is used to store the data, another one is used to store the link field. So this link field stores the address of next element. For example, this is my array. So in my array, I have 1, 2, 3, three number of elements in there. So this linked list storage means so this one can store like this. So this two can store like this. Three can store like this. So address is A, B, C. Here data field 1, 2, 3 address. So this address can be stored here B. This address can be stored here. This is the null pointer, for example. So this node address is A, this node address is B, this node address is C. Means B is stored here, C is stored here. This last node is the null node. So this is the single linked list. So different types of linked list are there. Singly linked list, doubly linked list, circular linked list, circular doubly linked list. Singular linked list, no? It's a normal 2D components. One is used to store the data, another one is used to store the address of next element. Doubly linked list, it's our three component. So one is used to store the previous node address. So this linked list is used to store the next node address. So this is used to store data. So this node is A, B, C. So this so this is stored the B next node address. So this front pointer used to store the previous node address A. This last pointer used to store the next node address C. So this previous pointer used to store the previous node address. So this last node is the null. Circular linked list means so instead of null, so this first node address will be stored here, A. So that is the difference between circular linked list and doubly linked list. This is some other example. In unit 3, we are going to discuss about tree. So tree means a node can have more than two childs, one child or two childs or three childs or four childs or n number of childs. So that is called a tree. Binary tree means a node can have at most two childs. That is called a binary tree. So this is called a node. This is called the edges. So these are the subtrees. So B and C, these are siblings. Which node doesn't have a child? That node is called the non-terminal node or leaf node. So till now we have discussed about what is the outline of data structures, what are the things we are going to discuss about in this subjects. So in first unit we are discussing about the introduction, memory allocation and regression. Unit 2 we are discussing about the searching and sorting. Unit 3 we have to discuss about the stack and queue. Unit 4 linked list. Unit 5 trees. Thank you.